Station 51, engine 27, engine 32, truck 105.
You're listening to The Fire Break with Steve Wolf. Hello and welcome back to The Fire Break. I'm Steve Wolf. The Fire Break is sponsored by Team Wildfire, developing innovative suppression and containment strategies for wildfire. I have got with me here live from London, and you'll be able to tell by his accent, certainly, Guillermo Rein. And Guillermo is a professor of fire science at the Imperial College in London, and he's also the editor-in-chief of the journal Fire Technology. So, he knows a lot about what we're here to talk about today. Welcome to the show, Guillermo. How are you today?
Hi, Steve. Thanks for having me. Just to that, my accent is not very British. I'm born and raised in Spain, but I'm an academic here in London.
I see. How did you end up going from Spain to London?
It was. I'm an engineer from Spain, and I wanted to continue studying and develop scientific background, and I did my PhD in California on studying fires in spacecraft funded by NASA, actually.
Oh, wow.
And when I graduated, I thought, well, that was an incredible amount of information that I gained studying my PhD in Berkeley. But I wanted to apply the knowledge to the planet Earth. I wanted to go back to engineering. And then I ended up in the UK doing all types of fires in buildings, battery fires, but also wildfires. And for the last 20 years, at least half of my research has been on wildfire.
Wow, that's a lot of research. And I bet the amount of things that are available to research is growing all the time because we have more wildfires now.
Yeah, in fires in general, it is true that humanity is very good at creating new hazards in the form of fire. So there is a need to keep an eye on those hazards and try to understand them and to develop solutions and to mitigate and prevent them. But in the specific case of wildfires, it is true. We are increasingly busy every year, busier than the previous, trying to understand new types of wildfire behavior, to develop new tools and new ways of protecting people from wildfire.
And when we think about wildfire, we're usually thinking about, vegetation fires in California or orchards or vineyards or forests, but and pretty recently you had some wildfire activity actually right there in London, didn't you?
Yeah, so we're in London, but we're a very international group, fire group. So we deal with fires all around the world. We even deal with fires that don't have a flame. Those will be smoldering fires, like it happens in peatlands, for example. But yeah, one of the most concerning, surprising, and weird events we've been involved with, which is a paper that, by the way, will be published next week, is this thing of what we call now a fire wave that happened here in London. So this is London, Greater London,
fire wave?
Yeah, it's a new term. I'll explain it to you now. So I'm telling you something that happened here in London, UK, the capital of the United Kingdom.
Yes.
So wildfires do happen in the UK, but their frequency-wise and size, they are not the type of behavior that you are concerned about in California or in Chile or in the Mediterranean, right? These are less frequent fires and they are not as big. But the UK knows about wildfires, small ones and infrequent ones, but it does. But what happened is that in 2022, in the summer of 2022, in the middle of July, there was a heat wave. Now the UK has heat waves even sometimes more than once a year. So unfortunately, we're getting used to heat waves. And the country doesn't handle well the heat of a heat wave. I'm from Spain, and I study in California. I can handle heat waves. But the country culturally and architectonically cannot handle heat. It's amazing, actually, Steve. It's quite a lesson. When you are in a country that knows how to handle heat, you go through very heat moments and you don't realize. But when you're in a country that doesn't know how to handle the way they do the windows, the way they dress, the way the shadow in the streets is not existing, is quite hot. So we were in the middle of a heat wave, and on 19th of July, suddenly fires started to pop up in the whole of England, but in particular intense in the middle of London, Greater London. And you would say, well, that's definitely not a wildfire. Well, it would not be the traditional wildfire, but it was actually the green space of London. In London, we're very proud of our green space because it's a big city with a big population. We protect and and enjoy tremendously the green spaces, the parks that we have, the gardens, being able to have a contact with nature, no matter that you are in the middle of the city. So this is what suddenly started to burn. We're talking about in the order of 400 wildfires in Greater London. And this is important. This was the busiest day of the London Fire Brigade since the Second World War. So this means that they were at war with wildfire. And if you talk to them, I talk to them often about this, it's something that they don't wish to see ever again in their lives. It came unannounced. It was very bizarre that suddenly the green spaces of London was burning. They knew how to handle it, but it's a different type of handling. They are prepared more to handle building fires, but they had to use the same fire engines and the same equipment to suddenly start fighting wildfires. And it led to, I think they lost almost like 40 buildings, which is unprecedented in the UK to lose buildings because of wildfires. No one died. We're very happy about this. But it led a scar in London, and it led a scar in the London Fire Brigade, because it didn't happen the day after. It literally happened only on the 19th of July of 2022. So we analyzed the data. The London Fire Brigade has a large database, has been collecting it with a lot of attention and love since 2009. It's open access to researchers, so we studied it. And what we discovered is that there is a correlation between what now we call fire waves. So not all heat waves will lead to a fire wave, but the extreme of heat waves can actually lead to a fire wave, which is an unprecedented number of sudden wildfires happening in London. And we saw that there was a weak correlation with temperature of the day. There was a correlation, but weak, with moisture of the day. What we saw is that combining all these in what is called VPD, vapor pressure deficit, which is a thermodynamic variable of the atmosphere that combines temperature and moisture. And to tell you what it is VPD, vapor pressure deficit, tells you the drying power of the atmosphere. Okay. So if the VPD, the vapor pressure deficit, is very high, it means the atmosphere is able to dry very strongly. And then if it dries, it means your vegetation starts to lose water, right? So it's under stress, and the air suddenly wants to dry it. So what we saw is that there was a criteria when the VPD has been very high for 10 consecutive days in London of really drying atmosphere, dries everything, even the grass in London, then there is a high chance of having a fire wave again. And this is now the only thing that we have here in London to prepare us if this is going to happen again. It didn't happen in 2023. It didn't happen in 2024. And as I speak with you, Steve, in May 2025, the question is this going to happen this summer? We don't know. No one knows. But the consequences, if it happens, are grave. So there is people, the London Fire Brigade pays attention to this thing.
So the combination for that, what do you call it, a vapor pressure deficiency? Deficit. So that would be high temperature with low humidity? Yeah. Right.
In a non-linear fashion, is exponential. It's interesting. Now, obviously, we're not the first ones to say that VPD have a correlation with wildfires. You will see papers that do this in boreal Canadian forests or in the northern forest of Australia. What is amazing is that this happens inside a city as well. This was not the forest of London. This was actually the greenest spaces of London. It was incredible.
So vegetation responds to temperature and humidity the same no matter where it is. The plants don't know that they're in a city. They just know that it's hot and it's dry and their moisture is evaporating.
Yeah. And any scary big wildfire is bad and needs to be addressed. Not all wildfires need to be addressed. You know this, right? There's such a thing as a good wildfire. But when a wildfire happens next to people, then automatically it becomes a bad wildfire that needs to be dealt with. In a city environment, as busy as London, any wildfire is not acceptable. So that means that when you have a fire wave, if there is a fire wave in a city, it's a very serious threat to safety.
So at what point do you call it a wildfire versus just a vegetation fire? If you have a vegetation fire in the park downtown, at what point do you say it's a wildfire?
That's a great question, Steve, because when we got the database from London Fire Brigade, I work with them a lot, but I never worked with them on wildfires, right? There was no case. but this happened in 2022. So we got the database. And if you go to the database, you have all these types of fires, battery fires, and you have facade fires. They don't have wildfire. So it's like, okay, if we were to stop now, London doesn't have wildfires. I thought, wait, I was there on 19th of July, 2022. London had wildfires. So we have to redefine what a wildfire is according to the London Fire Brigade. And what we did is we look for outdoor fires. The London Fire Brigade will tell you if the fire was inside the building or outside, right? So outdoor fire. For example, a car in the street will be considered an outdoor fire. And then we look into what is burning, and we selected only natural fuels. And then actually, pop, that's it. We got it. Just these two things actually qualifies as what we call now urban wildfire, which is natural vegetation burning outdoors, uncontrolled.
Uncontrolled outdoor natural fire. Got it. Okay, so that's so wild. So you basically had to go through all the data to find the criteria for a wildfire that were not called wildfire, and then relabel them wildfire. And when you did that, what history did you find that wasn't evident before?
Well, it was amazing. We discovered, for example, that the first fire wave was not 2022. There was two previous fire waves. It's incredible. One in 2010 and one in 2018. The London Fire Brigade, itself and London forgot about this. So there was people in London going through, right? But because it was not as big as a fire wave as the one in 2022, London had the capacity to absorb the damage, to respond and continue life as normal the day after. What a lost opportunity to analyze it and to learn from it.
Yes.
Right? Now, in a way, and I guess we are part of that answer, is in 2022, we were able to learn the lessons, or after 2022, right? Through this analysis and for our conversations with the London Fire Brigade. But it's so important, right, Steve, to highlight that wildfires has happened in the past, will happen in the future, some of them tragic. The importance of learning from the lessons and sharing the lessons so everybody can benefit, and we as a group of professionals should not forget about it.
Okay. So Guillermo, you said it's 10 days of these conditions. At the end of those 10 days, things are ready to burn. And possibly sooner, right, if the conditions were similar leading up to it.
It is. So what happens after 10 days is that the number of wildfires is unprecedented. So it's what we call, statistically speaking, outlier. So many of them. It's not London always have wildfires, but they're very easy to suppress. Someone has done a barbecue in the park. They call the fire brigade. They extinguish it by stepping on it. Oh, they stepping on it. Well, that counts as a wildfire. Yeah. We worry about when 400 of those happen, and 20 of them require several pumps, and some of them cannot be stopped, not even with the pumps, and start to burn houses. That is what we describe now as a fire wave. It's something unprecedented, unproportional, and it requires a very specific type of preparation, not just the normal preparation that any fire brigade would do for.
So you could look at this weather pattern, essentially, that creates the vapor pressure deficit, and you could look at that in any country, right? So you could monitor the weather service, whether it was California or anywhere else in the world, and you could say, okay, well, if these weather conditions are present and they're creating this vapor pressure deficiency over a certain period of time, you're going to get wildfires much more than normal. And so you're able to create, I guess, a prediction map for wildfire outbreak based on weather data anywhere in the world.
Exactly. And two comments on this, Steve. You are absolutely right. In a way, all around the world, we already do this, but we do it in a different way. We do it with the fire risk index. We do it based on statistical fires in the area. We do all these different things to forecast fire behavior and to create maps of risk. But all this is based on fires in the wilderness, in the proper forest, like literally away from cities. And if there is people, it will be just like remote houses, the wild urban interface almost. what we are discovering here is something very worrisome. It happens in an urban environment, not just urban like there is people in the street. It's like there is a lot of people in the street. There's a lot of activity in the streets. So the criteria will be different. And the way we were calculating the indexes and the burn scars, statistically burn scars, does not work inside a city. Literally, when you do these maps of risk and they arrive to the city, they stop. They show it to you in gray. And you ask like, oh, what happens here? There is no risk. You say, well, that's a city. City doesn't have wildfire, right?
Right.
So what this work, what happened in 2022 is a wake-up call for a lot of cities around the world. It happened in London. Remember, it's not the first time that it happened, but it's the first time that London responded to it. The question that we have as scientists is, which other cities in the world have gone through this but forgot about it or didn't share? And bet London was not the only one. And more worrisome is, which is the next city? Is it going to be Seattle? Seattle is very green and very moist. What happens if Seattle is suddenly under 2 consecutive heat waves? Are they going to suddenly have a fire wave? Because if it happens, Seattle is not used to this. And I bet the fire brigade in Seattle would want to know about it. New York? Sydney?
Yep.
The question is, we don't know.
Right,
Yeah.
they come to mind, right?
So we don't know. We think, and this is an hypothesis that I'm developing. It's 100% an hypothesis. I'm happy to be wrong, but maybe I'm right, and it will be tested by evidence later on, that I think this happens in cities that traditionally are in a humid environment. Therefore, vegetation is thriving. Green cities, they can be considered green cities, historically green cities that have been green and moist for hundreds of years, that suddenly find themselves in situations of extreme dryness that leads to extreme flammability. And then it rains. And when it rains, you know what? It goes back to the normal moisture. But before it rains, suddenly you have a lot of vegetation, which is in extreme flammability conditions. And you just need an ignition source or 100 of them, because we humans, although we don't want it, we are sources of ignition, accidental most of the time. In a city, you have ignition sources walking around in cars and otherwise everywhere. So that's an hypothesis. If this is the case, then cities that are typically green, but because of climate change or by other reasons suddenly, or because of human activity or alteration of their surroundings, they are suddenly seeing themselves with spells of dryness. They might want to pay attention to those spells, see them ahead, and prepare themselves when they are going through it.
I see. I want to drill down on one point you brought up. We normally say, okay, well, if you have this much fuel and this much dryness and this much wind, and then all you need is a source of ignition and it goes. How much study do we do on exactly what that form of ignition is? Instead of saying like, oh, that's, and then ignition, and then, well, you said most of it is caused by human activity. So specifically, what percentage of these fires are caused by which human activities? So that if we're trying to monitor our own behavior, we could know which of our behaviors are most likely to cause a fire. Is it the chainsaw? Is it the tailpipe on the car? Is it the cigarette drops, or like
the barbecue?
The
park. I can tell you one.
So have we done I guess you have, right? You studied like what percentage of activities related in what caused ignitions and what those activities were.
That's a great question, Steve. There is a lot of legends on that topic. There is a lot of truth in it as well, and a lot of common sense. But there's very little science. When people have looked into this, has been sporadic. It was not follow up. It was specific to a country or to a region, and there are strong difficulties to make sense of the science on this. So what happens at the end is that we all have opinions. Part of these opinions are right because of the common sense and the knowledge that we have, but it's very difficult to be certain. What we know for sure is that humans, unfortunately, unintended, are a very frequent source of wildfire initiation, unfortunately. It's not the only source. There is also the natural one, but we humans are involved in them very often. And we ourselves, we are not sure about the reasons. There are so many of them. We are not even sure. You just mentioned the most popular ones, which culturally speaking, I just want to highlight this. when there is good weather in London, in the UK, people love to take a portable barbecue and go into the park and have their lunch there with their friends and their family, right? When it's very, very dry, and because of the wildfires that have happened in the UK, now some authorities forbid barbecues in the park. And culturally, people are very upset about this, right?
Mm-hmm.
Because they're taking up something that they care about, enjoyment of the park and eating with the barbecue. And it's because London is very concerned about these portable barbecues, which is almost like an arsonist invention, right? They by themselves are a smoldering source with fuel that lasts for 3 hours that you can initiate, leave, and you can even not see it until the fires appear. So there was a strong response. There's still a strong response from the UK against this, right? They're not used to it. They're not used to their barbecues creating fires, but the conditions are such now that people have to pay attention.
Interesting. So could there be like a barbecue zone, where the vegetations have been reduced and the...
Yeah. So I travel now. I study in California, and I travel very often to the United States and Canada. This is what countries that have been dealing with these hazards, and at the same time want to have people that are happy dealt with, right? They have these metal garbage cans that are made of metal where you can dump your barbecue residue and it's safe. You have barbecue zones that you are saying that the UK is evolving in this. It's new. It's the fact that they have to be careful because of fire, not because of anything else. It's a new thing.
All right. So we're not so good at controlling human behavior, and we're not even sure which human behaviors correlate to what percentage of fires, which would be good to know, right? Because as you said, we guess based on common sense, but there's really not a lot of evidence to support, chainsaws cause 14% or outdoor firearms use 12%. Like, we just don't know on that. So we don't know what to reduce.
But yeah, you're describing it really well.
Beyond common sense, right?
Yeah, there is a massive need to educate society. And actually I blame this typically to fire engineers and the fire service and fire personnel, is that we collectively have been so successful protecting citizens that citizens forgot that fire is a hazard. They feel so safe. They're like trivializing it. They say fire, that never happens. That happens in the movies only. Why do they feel so safe? Because of the success of professionals, right? So now we are in a situation where not even the best professionals can keep them safe as often as before. And society is surprised. It's like, what is this? A fire? This never happened before, right? It's like, well, before you were feeling so safe, you stopped to think about your environment. The fact that our environments, our green environments, are flammable when they're very dry should not surprise anyone, unless someone is feeling so safe that flammability has never crossed their mind, right?
Yeah. Are there things that we can do in an urban environment where it's a small, relatively controllable amount of area to increase humidity? To using sprinklers?
Yeah. Actually, London, in London, you don't have to water plants because the weather does it. In Spain, where I'm from, you have to water plants because there's enough water, right? So there is a kind of like in between. So in Spain, you walk through the city in the spring and the gardens and the parks are being watered with sprinklers, right? In London, you hardly see these. You're like, what is that guy doing? Is watering the plants? No, you just wait for tomorrow. So maybe there is an opportunity here for London when it's under a heat wave to start thinking, well, we're going to start deploying sprinklers like they do in the south of Europe. Also, there is an opportunity because in urban environments, one can control the species of plant. You can control the vegetation. Yes. Not only to cut it, but there can be a selection of, we allow this type of tree, this type of brush, this type of grass. You can bring species that are more fire resistant. If you go to, just to highlight, it's very important for me. I grew up in Spain, completely different weather and a cultural approach to wildfires to the UK. So Madrid, the city where I am from, doesn't have fire waves. Yet it has a drying atmosphere, which is about 100 times the drying atmosphere of London. How come London has fire waves or had fire waves and Madrid didn't? One of the possibilities is that the vegetation of Madrid has adapted itself already to extremely hot summers. And what could have burned has already burned maybe 1,000 years ago. London might find itself and other cities in a transition where the vegetation of the last 500 years actually now, once every 5 years, once every 10 years, becomes a fire wave. That is something that could be happening.
I see. And tell me about the journal, the fire technology. What's the range of things that you cover in there, and what's new?
It's a journal that I love. Editor-in-chief for the last 12 years. Is the journal of the Society of Fire Protection Engineers and the journal of the NFPA, of the National Fire Protection Association. Both of them together share the scientific journal. And it covers all the aspects that you can imagine that has to do with fire. And obviously not fire in cultural context, but fire in a protection point, it's fire safety. Yeah. So it has a lot of wildfires, and this actually we see an rapidly increasing amount of submissions on wildfires as a testament of what is happening in the real world, that there is a lot of questions on wildfires because a lot of wildfires and a lot of losses are taking place. So there is a need to understand it that leads the science into it. But we also deal with fires in buildings, a lot of battery fires, a lot of industrial fires, all of the above. And as scientists, what the journal publishes is findings about this. So studies in many different ways, experimental, computational, in the field, based on observations of real events, data analysis, all of the above. But there are studies to try to find new things about this phenomena such that we can develop new technologies to protect people.
And that happens largely in the fire science community, right? Because it's a science journal.
Exactly. It's a science journal, so we embrace the scientific method, but we are to protect. So it actually combines fire engineering and fire safety professionals and fire science.
I see. So, but I would think that we're globally going to experience less wildfire devastation the more educated world populations are about fire, the more aware they are about it, the more conscious they are about their own behavior and participation in things that may lead to fire in terms of vegetation management. So to what degree or by what means are we seeing things that originated as science journal articles turned into public news stories so that people can educate themselves more about wildfire?
Yeah, so that's a really good question. So there is a very strong correlation between the amount of science that is available to learn from, this is what scientists do, and the later arrival of solutions and knowledge to society. But it is always delayed, right? So scientists produce the science, and then there is a significantly long process where people think nothing is happening, but it's actually the sharing and the learning and the combination of knowledge is happening. And suddenly new technologies, new ideas, new education, new articles, new teaching of society and kids appear. It's very difficult to create a direct link between the science and the improvement of society. But it is one of the main innovation sources of safety. Not the only one, but the main one, which is new ways of understanding what we're trying to avoid.
So you're not going to get changes in policy or changes in technical innovation without the underlying science.
Yeah, I mean,
right? They're dependent on the science. And then in some places, there's a disdain for the science itself and a repression of the science. And how can that not lead to more wildfire devastation and injuries?
We are living in interesting times, right?
There you go. Yeah.
So this is, I never expected this. I promise, since I started to study engineering and science, I was always told, and I always expected that the more science humanity will be doing, the better. But we are through interesting times, both in Europe and the United States, where there is now a backlash against science. Now, the problem with
I didn't know it was in Europe as well.
Yeah. In Europe as well. Yeah. This is new ways of looking into things, which is scary for me. because the consequences are unintended and they will appear later on. So, and it will not be good. And
Are they really unintended, though? I don't mean to be nefarious here, but it should be obvious to anyone that if you suppress the science, then you suppress the benefits that science gives you. And I don't see how someone could separate those two ideas.
I agree with you. And I think there is people who do not see what you and I agree on. Unfortunately, there is people who, for whatever the reason, and I'm trying to understand the reason as a sociologist,
Yes,
of why would people think that science was invented to help society. It's not an intellectual holiday of scientists. It's actually is something that humanity needs to progress. Now, it is true that the progress will not be immediate, and it will not be fast, and it will not be obvious. That is true. But it's the collective effort, continuous collective effort, that gives and pays off. Just to give you an example, just to be able to isolate into a personal experience, I've been working on engineering, fire engineering, and fire science for 20 years. So I am now quite happy, very proud as well, to be able to say that I've been involved I've influenced policy, I've influenced standards at the British, European, and international level, right? So I can claim that some of the things that I have found and with my team have ended up affecting and helping society. But I actually can tell you that it took a really long time. It's not that I published the paper and the day after there were the people calling on my door. It's like, oh, we are the committee. No. It required a lot of convincing to a lot of people at different levels with a lot of patience continuously. If you drop it, you almost have to go back. So, yeah, science is definitely for the good, but it requires patience, it requires continuation, and it requires that it will not be obvious to see, I put this money here and this happened. Unfortunately, that link you will not be able to make. You would see that there was 100 people working for 10 years on this, and look what happened 5 years later. That you could do, yeah.
I see. And it looks like the science becomes beneficial when it takes one of two forms, either policy or innovation and commercialization.
Yeah, these are the forces that combine our forces for the good. Yeah, there is a role for innovation, which is to do things in a different way and they are better. There is a role for the market to choose the things that can go forward and the ones that cannot because it's efficient and not efficient. There is a role for science. There is a role for legislation of fire safety, which is to make sure that what arrives to the market is safe enough. There is a role for citizens to say, no, I don't want this because it's dangerous, or yes, I want this because it's safer. All these things. There is roles for everybody here.
Or yes, I want this because it's dangerous.
I would not recommend that.
Different personality types, right? You said earlier, that science was invented to benefit society, to benefit people. Do you think science was invented, or do you think science is just something that is inherent in our brain that I've always felt like children are born as scientists.
Yeah,
They're curious, they experiment, they learn.
That's a great conversation. And I actually like science philosophy of science. I would personally think, I'm an engineer, I'm massively biased. I do think that we humans invented science because there are different ways of doing science. Not just one way. But it's scientific discovery process is always evolving, right? And we humans have been calling it in different ways. But there is something that you can call scientific discovery, right? Even no matter that has been changing, we can call it a scientific method. And something so human, right? The whole globe, different cultures, different climates, different histories, different languages, and we are united by that curiosity and that method and that experiment and that mathematics and the outcome that comes from it. That's typical of humanity.
Yeah. Well, when we talk about the outcomes that come from science and innovation and discovery and these eureka moments, to me, that stands in contrast to what we teach in school when we talk about the scientific method, right? And the scientific method implies that if you follow these 6 steps, you're going to invent something. And I've met a
We
lot of
wish.
inventors. I've never seen anyone arrive at some brilliant idea because they followed scientific method, right? They start with some crazy idea and they're passionate about it and they explore it and they, investigate it in every which way. And then when they go to explain it, maybe it gets written up as the scientific method, but I don't think that is a method for discovery of anything.
Yeah, no, there is not. No, I wish. And you're right. You're mentioning all the things that we don't teach the kids, which is the role of creativity. To do something crazy, it
Yes.
means that it's so creative. No one told you about it. It was just created in the role of doing it and getting it wrong. The experiment, not typically, the experiment never works at the beginning. For a very, very long time, actually never works. And suddenly one day it works. So the ability it's almost like resilience of the team. Because it's going to go wrong for sure at the beginning for a very long time. And the other one is not the determination. It's almost like an inherent optimism because so many things are going to go wrong at the beginning. The team somehow needs to keep moving forward. It needs to be optimistic. It needs to have determination and mission focus. All these things we don't teach the kids. Not yet.
No, but we should, and they need it there because we'll die one day, right? And we're going to leave all of our problems to the next generation, and if we haven't taught them how to creatively problem solve, they're going to be screwed.
Yeah, but it's very human as well. What we're discussing, Steve, is also very human. Curiosity is very human. Problem solving, I think, is very human. Helping each other and service to at least the immediate group that we see around us is very human as well. And we know there is human intelligence, so we have all the ingredients. It's just that the process is much faster if we do it together and if we do it consulting the previous knowledge. But if everybody has to start from scratch, that's going to take 3 centuries to do something. If we can learn from,
right?
stand on the shoulders of giants. Yeah, which is it's not easy to be. I mean, you have to read a lot to be on the shoulders of giants. They are giants for a reason, right? So it's not easy. Yeah.
Yeah. So what part is easy?
The celebration.
Like, what's the part that comes? The celebration. I
After
love that.
all the things that didn't work and all the pain, suddenly something works, and then that's the easy part, to celebrate it. And then it's very quick. Then you forget and you have to go back to work immediately.
Yeah. And a lot of lessons are forgotten. Like you talked about, in 2022, they realized it's wildfire. Well, there were wildfires many times before that, but nobody noticed, right? By 2025, they forgot the 2022 fire, and in 3 months they'll have forgotten the LA fire in Lahaina and Marshall and Paradise. Like, for a little while, these things are in the public consciousness, and then eventually we think of them as part of history, but not as great learning opportunities.
That's literally, you are hitting on the nail. The ability for humanity as a whole, all societies, to forget something that should not be forgotten because you need to share the lesson is incredible. In fire happens so often. When something really bad happens, I mean, as we speak, Steve, a few months ago, the city of LA, the beautiful city of LA, was burning. What is it? 10% of the city was burning. Tremendously tragic. I already start to see people forgetting about this, right? Obviously, these are people who are not working on fire science. They're not fire engineers. They're not fire emergency personnel. I understand. They forget about this because they can afford to forget about it, right? Because they have other things to do in life, and because fire is not constantly happening to them, so there's like, oh well, I just forgot about it. But collectively, we cannot forget about this. Is what you're saying? We cannot, because it's not that we have immediately all learned the lessons from the LA wildfires and we are immediately going to start building cities the right way. Not at all. Actually, probably we have not learned much from the catastrophe in LA just yet. It takes time. It takes time to learn. It takes time to pass those lessons so that they can start to be implemented in the real world.
Yeah, and so many lessons, so many different, even just within fire science, so many different ways to look at this and so many different conclusions to draw from it.
So a lot of this, a lot of talking, a lot of communicating, a lot of sharing, a lot of reaching out to each other, a lot of working together. That's something that we need.
And in what forums does that happen for you? Because I would think that when scientists are sitting around and they're reading paper from the podium, and they're asked to submit blah blah blah. Yeah, maybe there's some knowledge that moves between people, but I would think that the informal conversations
Yeah.
Probably a lot more content.
So I can tell you now, in my career, I've learned that all of them are necessary. You're describing the most academic one, which is very arid. I 100% understand. We academics are difficult people. And the way we prefer to communicate from the podium and the papers, that is difficult. It's arid. It's not the most.
It's vapor pressure deficient. It's hot and it's dry, but it goes on for a long time.
But there is no good replacement for this. This is scientists talking to scientists. We just learn how to do this. So that has to continue, but that's not the only thing. Not at all. That might be only like maybe 20%. There is the scientists talking to other people, other professionals, other stakeholders, and other stakeholders talking to scientists, right? Both ways. That is where we have more space to grow, because we have a lot of scientists that are only talking to scientists.
Right.
And the problem is that only, and then they don't develop the muscle of communicating to other people. I see this happens very often in engineering. That in engineering, our students are incredibly smart, but they maybe are not the best communicators. And that's fine, because it's not a requirement in engineering to be a top communicator. But then humanity loses a lot by not asking their engineers to improve their communications, because talking among ourselves is great, but talking more to the outside circle is actually very important.
Yeah, right. You have a big circle of people who are scientists. You have this circle of people who are journalists or entertainers or educators. And then the overlap in that Venn diagram is very, very small, where you have people that are called science communicators. And
very small.
Right?
Unfortunately, very small. I was never trained in communicating. I just realized by being in the US, by the way. I'm from Spain, remember. When I arrived to the US, I realized that the US as a culture is so much more communicative than my own culture in Spain, especially on professional basis, right? I was going to a university. I was not able to explain to anyone what I was doing, except to my colleagues in the class. I could see American kids being able to explain to anyone what they were doing. Oh. And I realized, I said, I want this. I don't know how they do it. I want this. And obviously people say, well, this is how they grow up. And I said, no, I want this. I am going to develop that muscle. And then by exercising, by trying, by imitating people that communicate, and it's like, oh, I want to communicate like this, then some muscle started to develop. And this is something that I try to teach my students. I said, you have to be really smart. You have to do amazing models, amazing experiments, amazing papers, amazing grants, amazing awards. But you also have to be amazing at communicating it to someone that is not a scientist.
Well, you're very good at it, and I think it's it's partially a learned skill and a practiced skill, but also a lot of it's personality driven.
Well, to communicate, this, you're a professional at this as well. One has to want to communicate, right? If one doesn't want to communicate, then it's not going to work. But then it's not enough wanted to communicate. But that's maybe one of it's a necessary but not sufficient step. And then it's the practice.
And the desire to communicate is based on the why. What is the result that is important to you to achieve?
Yes, it's like, oh, that's beautiful. Yes, exactly. It's the one thing to communicate is because the outcome is something that is desired. And the outcome that I'm calling for is helping others, right? We happen to know a lot about the things that we do, but we can help other people by communicating it. And that is something that calls for communication.
So helping people is pretty broad topic. There's so many ways to help people, right? You could cook for them, right?
Yes.
Tell them their hair looks nice. I could say you have good looking eyeglasses, right? Yeah. And you're really, confined to this area of helping people through fire science. And fire science itself is even a huge area. Is there a particular area of fire science that you're most passionate to communicate?
Yeah, so which is the hard one is the fire science that I do is hardcore fire science. We solve mathematical equations which are very complex. They're not straightforward at all. We love them, but they are difficult to explain. They are not transparent. They are not straightforward. It requires a lot of years of study, and then we solve them in the computer, and then we get those computer models right by validating against the experiments. So the experiments have to be also really detailed and have fidelity, and then they have to be useful. So then we talk to stakeholders outside the fire science, firefighters, engineers, authorities. The whole process is not straightforward to communicate at all. Starting from the beginning, when you try to communicate the equation is when things are really hard, right? Because
Sure.
most people, unless they're like us, they're like that. You've spent more than 10 seconds on that equation. This is getting arid already.
Yeah. And even what we call fire science, I imagine, has changed dramatically. If 50 years ago you took a course on fire science, you were probably studying fire suppression.
Yeah, well,
And
historically there's a lot of emphasis in what's the only thing. A fire. What is it that you do? The only thing that you can do is suppress. No, we know that there is so many things that you could do, suppress as well, but so many other things that you can do before and after that is not just suppression. Yeah.
when you talk to your students, and you have a fire science division, and now we're seeing fire science divisions in from Australia to London, many places. What are the things that you have found enticed students to come and want to study fire science? Because if we
So
do more of that, right, then we can get, if we know what's drawing them, we could get more participation.
by far, the great majority of fire scientists didn't know about fire science until quite late in their professional careers. So
How
it's not that a
interesting.
kid was learning a comic or watching a movie and saying, "I want to be a fire scientist." So most people, when they come across fire science and the fascination starts to develop quickly, the first step is, what is this? Is this a thing? Are you pulling my leg? Fire science exists. Can you put the two things together? That's amazing. Well, so we should expose more people to that,
Earlier.
because it is fascinating, and
Yes.
it is challenging. In people that like dealing with challenging problems, dealing with fire science is challenging, and the rewards are immediate. I mean, immediate in the sense that there is such a need to understand fire, and there is such a need to protect people, that it is a fruitful endeavor. It's not just that we do fire science and it's difficult, but no one cares. It's that it's difficult, and then the results, there is all these people that are waiting to use the results to develop new suppression, new prevention, new detection, new mitigation, new evacuation, etc.
And are the people who are studying fire science, and you said they usually come to it late,
Yeah.
were they people who had just gone into science but later discovered fire science, or were
Yeah.
they starting in other areas and then came to science?
So the great majority of us in fire science, when we get together, we are tremendously diverse in our backgrounds, and the way we end up into fire. Some started with chemistry, physics, mathematics, engineers, electrical engineers, ecology. I mean, literally, you put them in the room, and it's incredible. We might be talking about the same computer model, but each of us have such a different path to reach to that room. It's incredible. That is a strength of the field, the diversity of approaches and ideas and the creativity, but it also creates problems, for example, with nomenclature. We do not mean the same when we use the same word, or we mean the same but we use a different word. That the diversity also has its drawbacks, and nomenclature and the fact that the communication has to take longer because there are all these initial misunderstandings. That is also characteristic of fire science.
Fascinating. Let me ask you one more question. Why do you think historically, through prehistoric, caveman and behind, we have such a fascination with fire?
Great question. Some sociologists think that it's in our DNA. There is a concept of DNA memory, which are things that we think we can remember, but it is not in our brain. It has to be somewhere else, maybe in the DNA. Such a thing exists in psychology. So there is a theory that says that we spend as a species so long in caves looking at fire and that this fire suddenly brought comfort and cooking and warfare and light. It brought suddenly so many positive things for humanity. They say it's the beginning of civilization. And it was all contained into this phenomena, this flame. And we spent so much time looking at it that it became a memory in our DNA. And this is why we use this. When we have a visitor to Imperial College, very often they say, Guillermo, we have a very important person here, an ambassador or a president. Can you show them your lab? Because in 10 minutes, we can show them flames that immediately call for this fascination, right? They're like, oh, wow. Unfortunately, that flame is beautiful. And it's like, how? I mean, that flame is dangerous. And this is what we do in fire science. But it's true. Looking at it is tantalizing. Why? It has to be something about sociology and humanity.
It moves, and it's not there. It's very much like television or a movie.
It is
right?
television, right? The only similar is computers for our youth and phones that are addictive, and television. Yeah, it's like when it's on, I see this in the lab every time. There are two types of broad experiments that we do broadly, right? We do flame experiments, flame spread, which you see the naked flame in the lab. You can actually see, if you are not careful, you can actually burn yourself. And a smoldering combustion. Smoldering combustion doesn't have a flame. So you take someone into the lab visiting, and you have to one side the flame, naked flame spreading, and on the other one you have a smoldering. They cannot see the smoldering experiment. They cannot see. They could be just a meter from it, and they can only see the flames. It's incredible. You take them out and you say, do you see the experiments? And they say, which one is the second?
Wow.
So the flame calls for for example, camera crews know this. When they say, oh, Guillermo, we are from the BBC, we would like to have some footage for an article on something that has happened. Can we show some footage? I open the door for the lab. They immediately see the flames. The cameras are rolling. Immediately, they're like, oh, amazing. And they get close and they get far. And I say, oh, look, we have here smoldering. No, I don't know. No one cares about that. It doesn't have a flame. No, but these are the biggest fires on Earth. This is smoldering. No.
You're right. You have underground smoldering fires that have been burning for hundreds of years.
Yeah. The peat fires in Southeast Asia are officially the largest fires on Earth, because they lasted for 3 months and they are three-dimensional. So they burn an absolutely incredible amount of fuel, of forest, more than the cars of the world produce in carbon emissions. But they don't have a flame most of the time, and that means it doesn't tantalize. It becomes an obscure topic that only a few people do.
Well, we could relate this to marriage and relationships in another episode, right?
Of flames and smoldering.
Yeah, right. That the smoldering flame is the one that lasts a long time, and the right, the bright, magnificent one is beautiful, but it burns out.
Yeah, I like it, Steve. You're very philosophical. Yeah, actually, there is something about this, man.
Well, this is a whole other area of science that we'll maybe have to get into another show. But I love your idea about this DNA component. That maybe as we unravel the human genome, we'll find the fire gene.
Fire gene. I like it. The fire gene.
Wonderful. Guillermo, thank you so much for joining me on the show today. Just such a pleasure to chat with you.
Thank you, Steve. I really enjoyed the conversation. Thank you.
Same here. Guillermo Rein from the Imperial College fire science professor and the editor-in-chief of the Journal of Fire Technology, which is just called Fire Technology. Guillermo Rein, thanks so much for joining us, and thanks for watching The Fire Break. I'm Steve Wolf. We're sponsored by Team Wildfire. Till next time, be careful and watch out for those human-caused ignitions, because you're the human.